Good day, everyone. Today, we are going to discuss all about the chain rule applied specifically to algebraic and trigonometric functions. By the way, the chain rule is a fundamental technique that allows us to differentiate composite functions, and these composite functions are functions that are inside other functions. And by the end of this lesson, we will be able to understand the chain rule, identify inner and outer functions, and solve complex derivative problems efficiently. Moving forward, we have our objectives, which is to explain the chain rule for algebraic and trigonometric functions, apply the chain rule to differentiate composite functions, solve complex chain rule problems, and identify inner and outer functions in composites. Now we have our chain rule formula. Chain rule is used for differentiating composite functions. Composite function is notated as f of g of x. And for the derivative of a composite function is given f f of g of x is equal to f of prime of g of x times g of prime of x. So there are two functions involved, and this general formula is applicable for algebraic and trigonometric functions. Now we have our rule for trigonometric functions. Here are examples of composite trigonometric functions. We have y equals sine 3x squared and y equals cos 5x plus 2. Now these two trigonometric functions is very applicable for the chain rule since we see a composite functions. This here is our outside function and this here is our inside function, the outer and the inner function, same as here. Now we are reminded for the formula. The derivative of cos is negative sine times the u, which is the inside or the inner function, times the derivative of the inside function, same as here, which is applicable in this given trigonometric function cos 5x plus 2, since the derivative of cos is sine, and then the u represented here is the inner function. That will be equals to cos, which is the derivative of sine, times the inner function 5x plus 2 times its derivative of the inner function. So we will discuss it furtherly. Now to understand clearly about chain rule, we have our complex problem number 1, which is an algebraic function. So we have here, we are going to differentiate the function given y equals 3x squared plus 2x plus 1 to the fifth. So the first thing that we need to do is to identify the inner function. So we know that the inner function is enclosed with a parenthesis. So basically our inner function is 3x squared plus 2x plus 1. And then our outer function is y equals u to the fifth. Since from our formula here, u is our inner function, or it is something that represented of the function. So it is y equals u to the fifth, since we see that our power is it's to the fifth, and that will be our outer function since we don't see a leading coefficient over here. So now to apply the chain rule, the first thing that we need to do is to get the derivative of the outer function, which is the u to the fifth, and applying the power rule, that will be equal to 5 u to the fourth, and our u is the function which is applied here, 5u to the fourth, and since our u is 3x squared plus 2x plus 1, then now it becomes 5 times the quantity of 3x squared plus 2x plus 1 to the fourth, times the derivative of the inner function, which is 3x squared plus 2x plus 1, which is 6x rather plus 2. We know that the way of getting the derivative of this one is simply applying the power rule for this, which is to multiply the power rule to the leading coefficient, which is 6x, and then the power rule will be subtracted by 1, so 2 minus 1, that's 1, so now it becomes 6x, and the derivative of 2x, that's 2, and the derivative of 1, and that's 0. So basically, the derivative of 3x squared plus 2x plus 1 is 6x plus 2, and that satisfies our formula f prime of g of x times g prime of x, and also it could also be expressed as u and the prime of u, which is here it is the inside function, and then that inside function will be derived. That's for our complex number 1. And now for our complex problem number 2, which a combination of trigonometric and algebraic function. Now we are given differentiate y equals sine times the quantity of 2x cubed plus x. So first we are going to identify the inner function, which is the 2x cubed plus x, and then our outer function, basically that's sine times sine u. And then to apply the chain rule, that's dy over dx equals the derivative of sine, that's cos, since there is no other function, and then u is just copied, times the derivative of the inner function, which is 2x cubed plus x. And the derivative of 2x cubed, or 2x to the third plus x, is 6x squared plus 1. So we just simply multiply the power to its leading coefficient, which now becomes 6x, and then talk about the power rule. The power will be subtracted by 1, so now the power becomes 2. So basically it became 6x to the second, and then the derivative of x is 1. So basically the derivative of the inner function 2x cubed plus x is 6x squared plus 1. So now combining all the answer, the derivative of sine 2x cubed plus x is simply cos 2x cubed plus x times 6x squared plus 1. We are now in our complex problem. We are now in our complex problem 3, which is a multiplication of trigonometric function and algebraic function. Now we are going to differentiate the function given y equals cos times the quantity of x squared plus 1 to the third. Now the very first thing that we need to do is to identify the inner function of the given function, or the given composite function. So in this case, our inner function is x squared plus 1 to the third. And our outer function, that is cos. We have our cos as our outer function because we see it evidently from this function that its outer function is the cos itself, and we just simply copy the u since inner function is not involved. We are just going to get the outer function. So now applying the chain rule to get the derivative of the outer function, dy over dx equals negative sine u times du over dx. So we just highlighted the outer function here, and we will be discussing or tackling the derivative of the inner function, which is represented in this way. So again, the derivative of cos is negative sine. Now we are going to get the derivative of the inner, which is represented as du over dx from here. So du over dx equals 3 times the quantity of x squared plus 1 to the second times 2x. Since the next thing that we need to do is to take the derivative of the inner, then what we did to have it this answer is that we simply bring down the power, which is 3 here, and then we have subtracted 3 by 1. So 3 minus 1, that becomes 2 in the power rule. And we just simply copied the inner function since we are not yet done with it. And so that we can proceed with the next process, which is to get the derivative of the inner function x squared plus 1. Since we were not able to solve it directly because there is a power involved. So before we could proceed by getting the inner derivative, then we will simply first tackle the power rule. So x squared plus 1, that's the derivative of x squared plus 1, that is 2x, since 1 is 0, becomes 0 in its derivative. So by multiplying rather 3 times 2x, that is 6x, and then we just copied simply the inner function, which is x squared plus 1 to the second. Combining our answers, we have obtained negative sign times x squared plus 1 to the third times 6x times the quantity of x squared plus 1 to the second. So the very reason why it remained as represented u here, because of course we are not going to forget to copy the inner function here. And then before we could add the derivative of the inner function. So to summarize everything, the derivative of the composite function f of g of x is equal to f of prime of g of x times g prime of x. So we will just simply substitute the value of the g of x to the x of the f of x. And then after that, we are going to get the derivative of the inner function and talk about when it has power. Then of course we will simply first define it, and then after that we can now get the derivative of the very inner function. And then to apply the formula, the first thing that we need to do is to identify inner and outer functions first, apply derivative rules for algebraic and trigonometric functions, which was discussed earlier, and this chain rule is useful for complex functions. And that would be all for our discussion. Hope you have fully understand the chain rule even in complex functions. Thank you. And if you have any questions, just message me in my Google account. Thank you.